Thanks very much. Right, I'm billed as innovation in academia. So I'm an academic. That means that I teach things. So I'm going to teach you some stuff as part of this. Well, so we'll have a bit of teaching and a bit of the trampoline story and some of the lessons. So you're going to get the lessons for a start. Here's the outline. There's a roadmap with 4 themes, and there's the trampoline story in the middle, once you start getting bored, and at the end, then when you've been excited again, we'll talk about what's a good idea and how you might understand what a good idea is. Now, I don't pretend to know everything, so it's up for debate. All the people from industry know that academics don't get it right, so that's okay. I'm quite happy with that. So here are the 4 themes that I want to talk about. I find that students don't really get the whole innovation process. It's a big, complicated process, like lots of things that we do in the world. I've broken it down into 4 pieces. So there's the technology piece, a market bit, business, and finance. Doesn't mean you have to break it down into those bits, but that's the picture I have. And I have a stool here with 4 legs. If one of the legs comes off, you can still sit on a 4-legged stool with one of the legs off, but you're likely to fall over sooner or later. So what are these 4 themes in a little bit more detail? So for a new product to get to market, you've got to meet objectives in the 4 areas here. So for the technology, the product has to work and it must be able to be produced. And those are technology issues, and engineers handle that. I'm an engineer, so that's my territory. I'm comfortable there. The market, I'm uncomfortable in the market, but there must be a market and there must be customers. You don't have a customer, you don't have any product. And they've got to buy it at your price, and there's got to be a path to that market. So this is not my expertise, somebody else's expertise. The business, that's not my expertise either. I'm not a good business person. The business needs to be built around the product, and it's got to have the right team of people. So that's another one of the legs of the stool. And the last one there sometimes gets overlooked. There must be financial support to do the job properly, and that means money going into it to get a new product to market. Now, for each of these theme areas, there are people. For the technology, you've got, well, here's me, I'm the engineer, in this case the inventor as well. If it's Bill Swallow, he's the scientist. A designer, product manager, manufacturing manager, these are all to do with the technology. So these are people that I'm comfortable interfacing with as an engineer myself. Then the market is the customer. I sometimes interface with the customer, but usually I prefer to be in the back room. There's an entrepreneur who knows how to make lots of money out of the market. Business development manager, marketing manager. These are all people that I don't really understand very well. They go in the commerce building. The business, any business such as McDonald's or placemakers have directors, chief executive officer, financial controller, accountant. That's stuff that I don't really want to get involved with. And then there's finance to support a product in the process. Research fund providers, we do interface with those from university. Pre-seed and seed fund investors at university, they are sort of beyond what we do typically. And venture capital investors, and that's sort of out of my territory too. So there's a lot of places, a lot of people here that I don't necessarily interface with very much. Then we've got this picture here, which is product innovation process, a proposed roadmap. I found that people just got totally confused about all of these things, and there was no idea of where to go. I'd just like to go over some of the main features there. So there's the 4 themes here, starting the technology stream there, and then there's the market stream and the business stream, and over the top there is the funding, and you can see all these dollars coming down from heaven, which would be a wonderful thing. This picture here is this top part is the part we're going to look at, and it's really a timeline. It starts from the left, and it says IP ? Intellectual property. Do I have some intellectual property? Maybe I've thought of something. First thing to do is technological proof of concept. We've got to make this thing work. Is it likely to work? And then you might have some sort of assessment of, could this be something that we could sell? You're not sure, but you'll have some sort of, ask a question. If you say absolutely not, then there's a big stop sign. If the answer is yes, then you might want to do some intellectual property protection, or else keep it secret. It might not happen there, it might happen somewhere later, but I'm just suggesting it's somewhere on the timeline. At this stage, I have chosen to form a company around the intellectual property. So this is StartCo, the startup company there. And Each of these streams goes through a number of processes. So for me, I'm comfortable with this one here, the technology stream. Prototype number 1 is a little bit better than the very first proof of concept. Prototype 2 is getting a bit better. Prototype 3 might be something that I could take to someone and let them have a try, but I'm developing prototypes, and at some stage I'll take it to people to let them have a try of it. I might have some pilot production and then early stage production. So that's the technology process, and as an engineer I'm familiar with that. But parallel with that, I need to have other people working on this market stream here. They need to validate the opportunity. In particular, they really got to get close to the market, find out what the market wants, find out who the customers are, find out how much they're prepared to pay, figure out how the customers want it delivered, and so on. So this is a big, expensive process. A lot of people doing quite a lot of work. It can take a couple of years for people to actually sort that out well. Once they know all of that, the marketing people may be marketing it, promoting it, coming up with a marketing program. Parallel to that is a business stream. It might start off pretty small, a couple of guys in the garage, and you won't have an HR department in that case. As you get further down the track, you've got to put a team together, and somewhere you have to have a business strategy and a premises and a phone number and a website and a brand and all of those things. But at the start you won't have those. So somewhere down the track you've got those, an HR department, an accountant, and then along here you're actually running the business. And then there's the finance stream here, which we've talked about before, and I don't know much about except these early stage ones where we might get funding at the university, but you need to get funding coming in. Somehow you've got to get that money coming in to make the product go. An important part of this is this end here. You've actually got some production, some product getting to market, and at that stage it's becoming something of a valuable company, and someone might want to buy it out, and that's what I've got here. Do we sell out at this stage and sell it to somebody who wants to take it further? All right, so there's the basic roadmap. Down the bottom are things that people typically don't understand, and I've added it to it, and it's sort of parallel on the timeline. First thing here, it says 5 to 8 years. Most people who haven't done it before say, no, we can do this in 6 months. People who've done it before go, is 8 years long enough? So you can argue about that. Some things on the internet, you might get it there much quicker. If it's a mechanical widgety thing like mine is, then that's probably realistic. Here I've got a line for investment risk. I'm saying here 98% risk. Someone has come and they said, I've got a patent. I'm the investor. I say, very risky, 2% chance of it getting anywhere. The other end is 50% risk. So now they've got something into the market, just starting to sell the first few of them, 50% risk. The risk has gone down. That's the main thing to realize. The cumulative costs here. How much it's cost me $1,000 to do a patent. That's pretty cheap. I might have done it on the cheap somehow. But you'll see the costs as I have to pay for these people to do a market survey. I have to pay for these pilot production and so on. And we've got $150,000 have been spent. If I was doing that myself, the house has been mortgaged now. And if it doesn't go, I'm dead and divorced and all the rest of it. It's a big problem. That's why you need this money coming in. How do we get that money coming in? We'll come to that. The perceived value, the point here is the perceived value is much less than the costs. Peter Berkman always says to me, someone's got a patent, they come to me, I've got this great idea. He says, I'll give you $5 for it. Until you've done this market assessment and got it into early production, it's not worth much. So the perceived value, you see, stays lower than the costs all the way along here. So if you sell out somewhere in the middle here, you're not even getting your money back. But once you start getting it into the market and you've proven that there's a customer base, people are willing to buy it, then the perceived value's gone up right at this end here. So that's a really important thing to realize. The value goes up towards the end once you've got something into the market. And then if I had a share in it, if I'm the typical inventor that's all about the ego and how great I am, down here I've got 100% of the share, and the value is $5. I've got 100% of $5, and as far as an investor is concerned, you can keep that if you really want to. It's not going to go anywhere. But if I want to get funding to go further, what I've got to do is to sell off my share to people who think that it's worth something. So I've sold off 20% of the share there. I've only got 80% left, but I've got some dollars coming into the process. So I sell off my share to the investors who are prepared to put money in and take more ownership. And at the end here, I've only got 20% left. And the inventor would be horrified with that, but I've got 20% of $450,000, which is $90,000. So I'm much better off than having 100% of $5. So that's the picture there, and I find that quite useful when anybody comes to me and they're partway through the process. I can sort of say, well, you're about here, and here are the issues around where you are. All right, that's lesson one. You've done well. I see everybody's sort of eyes looking at me, attention. That's good. So now we have the trampoline story. In brief, we can't fit 5 to 8 years in 5 to 8 minutes very easily. So SpringFree Trampoline, here's the SF90, the old one that we started with. Won the US Product of the Year Award 2010, and you're allowed to put that on your product if you've done that. Invented in New Zealand, Campbell Live put it in the same class as refrigerated shipping and the Hamilton jet boat. I mean, he needs to sort of promote things and get media coverage. I don't know whether it's up there, but people like to think that. So in the beginning, it wasn't like that at all. 1989, I've got a 2-year-old. I'm thinking, I love trampolines. When I was a kid, I'd love my daughter to have a trampoline. Talk to my wife, we need to get a trampoline, dear. She says, no, dear, they're too dangerous. And I go, well, they were never dangerous. I mean, they're a lot of fun. You have to be careful, but... so a little bit of tension between me and my wife. And I go and have a look at the papers, and I find Dr. David Chalmers, University of Otago, has written a classic paper, A Decade of Injuries. He's looking at injuries, alerting people to trampoline injuries, and I read this paper. Creates more tension between me and my wife because she was right, you see. So I'm thinking, I'll do something about this. I'm an engineer. I know lots of things, don't I? I can fix this, maybe. So my personal goal, make a safer trampoline, and I thought soft edges was the way to go at that stage. Now, Heisenberg says if you want a good idea, you have to have lots of ideas. So we'll look at some of the ideas on the way. So here's idea number one. Here's my 2-year-old son bouncing on, this is a sea biscuit that I borrowed, and I put springs around the edge, tied them on there with ropes that go underneath, and there's a little trampoline mat which we had sewn up there, and he can actually bounce on it, even late at night when he should be in bed. That was quite interesting. It worked all right, I thought, so that stimulated me to take the next step, and I designed one up and had one purpose built, and here's a picture of it. It's a bit later. This 2-year-old is now 4. Here's an octagonal thing, done away with the springs, which is a good thing. It's got the mat in here. Some good features, but the materials cost made it too expensive for young families. $800 just for the materials before you start, really. Not very bouncy. Now, there's arguments about that. I wanted it bouncy, but a mother with small children doesn't want this sort of child bouncing way, way up here. So something that's not very bouncy is quite good. And low is good too, and it's rounded edges, they can slide off, they can't hurt themselves. Parents are happy with that. It always leaked. You blew it up with a vacuum cleaner, and a couple of hours later it would be going soggy again. So it didn't matter what you did, it would always have a leak. So it had problems. Not a good thing to put into the market. So here's some of my sketches from around that time of other things. I wanted to make a bouncier one. So we've got, here's a spring here, and here's a bit of frame here, and there's a picture of something that looks like a drum down there. So that's part of my thinking, coming up with different ideas. There's a whole book of these sorts of sketches. I had a student project once I started here at university in 1996 to make that one that looked like a drum. So here it's got sides on it. You can push those edges there and they'll move like the edge of a double bed or something. She looks as if she's easily jumping that high, but that's a lie. She's not easily, she's working really hard at it. It was one of the most non-bouncy trampolines I've ever come across. It was very soggy, but the edges were soft. So we'd achieved something, but not all that I wanted. This is what it looked like underneath. It had a soft edge, but was very complicated. Twice as many springs as a normal trampoline of that size, so therefore, much more expensive. Not a good idea to go much further. I had another idea, and I was trying to think of, here's what looks like the edge of that inflated trampoline, but I wanted to make steel rods like that, that would sort of be covered by fabric, and steel rods would have some springiness. And here's my vise and my, you've got to have a garage if you're an inventor, and I've got a piece of wire here that's bent around in that shape, and I'm pulling on it, measuring the tension I can get, and I've got little data down here. I was sort of trying to figure out what loads I need, how big I needed to make it. Turns out I needed to make it 10 millimetres thick. A 10 millimetre bar that's about this long is really heavy, and 90 of them is 90 times as heavy, and it's also pretty expensive. So it wasn't really going in the direction I wanted to. So I had a colleague in mechanical engineering who said, well, why don't you use pultruded fiberglass, it's a great material, much lighter than steel. And I thought, well, it's not curved, I want it curved. Started thinking about it. He says, well, fishing rods are pultruded fiberglass, so he's got a picture of a fishing rod up there. Stronger than steel, you can get it in New Zealand. So I started thinking, well, how can I do this? And I thought, well, maybe I can deal with a straight one. So here's my idea number 5. You get the straight one, you stick it into a hole in the ground or in a round frame, and you bend two of them in towards the centre, and you stretch a piece of string between them, and of course it's going to be tight, and that's what you need. All around the edge, you need these things to hold the mat tight. So that was not a bad idea, except if you land on it, it's not comfortable. You can impale yourself. Not a good idea. Then I had the idea of laying them over. So this is what I'm trying to show in this picture here. It's a bit hard to see, but I've laid this one over like that, and this one laid over like that. So then if you land on it, it's actually flexible. So that was probably the innovative step that made it all possible. But would it work? I got pretty confused about whether this sort of thing was actually going to work or whether it would just collapse when you stood on it. I couldn't figure it out. So I had to make one. So here's this made in the workshop. Here's the first one. It's my sewing there, which is not very good. I did it when my wife was out, so she couldn't criticise too much. But here, there's kebab sticks there, and that actually would bounce things for a little while, until the kebab sticks kind of cracked a bit and lost their spring. But it proved that it didn't collapse. So then I got a student for a summer project, and he spent all summer and he made this one here. So here's the very first SpringFree trampoline. It has pultruded fiberglass rods down the bottom. We decided to cut the mat into sectors. We thought it was very important to do that. It really made no difference at all. So it was another idea that was a useless one. We've got soft edges on it. And I thought, right, I'm now in a position to perhaps approach somebody and do the commercial thing. So I went to Canterprise and they said, well, we're too busy, but if you know who you want to talk to, you just go straight to them. So I went to Supertramps in Levin, and I rang them up and he said, send us some photos. I sent him some photos and he said, well, I'll be down in Christchurch, I'll come and have a look. That was pretty exciting for me as an academic. I've got a commercial relationship, wow. He came down and he had a look, and he didn't like the cake tin one, which is the upside down one that was very soggy, but he did like this one here. But the first thing he said is, yes, okay, I like this, but it's got to be bigger. That's too small. It's got to be higher. It's too safe when it's that low. It's no challenge for kids. And then it's got to come apart for packaging, and then it's got to be able to be assembled by a solo mother with no tools in half an hour on Christmas Eve after she's had a glass of wine. We never ever achieved that. But commercial relationship, me as an engineer, I didn't think of all of those things. But so we set about doing that. Because we had a commercial relationship, we could get some government funding. That paid for one of those students to work for 6 to 8 months. And he and I worked on a 10-foot one, which was bigger. The other one was 8 feet. So this is the 10-foot one. And here's the pieces. It does come apart. Very difficult to get apart. But anyway, we could get it apart. And we were able to show that to our commercial partner. It had little problems. We couldn't figure out how on earth we were going to really connect things to the edge, and we've actually got 6 different versions of edge fittings around there, but at least it worked. So over the next few years, the student went away, the commercial partner just kept saying, well, this is not good enough, perhaps you could change that. And so we went about changing things. So for a number of years, until about 3 years later, we had this version here, the 10-foot version, and I'd now got some plastic fittings that were injection moulded, that fitted in the edges. I thought that this was pretty good, but he kept on. Every time he would say, oh, it's pretty good, but it's pretty good, but we never. I was hoping I was going to get the market the next year. We never did that. The time went on. Canterprise said, okay, let's have a look at it. So we had a visit from the people in Canterprise. So here's Terry Fullerton, Chief Executive of Canterprise. Here's John Rain, who is professor at the moment. Here's me looking all nervous and worried. And they had a look at it, and the decision was, this is not market ready. This will take $50,000, $100,000 to get it market ready. You've done pretty well, but just keep going and goodbye. And I was devastated because I thought it was market ready. I was learning, see. Nobody was saying, right, well, you need the money, so here's the money. So I didn't know what to do. But what happened around about that time is Enterprise, and that's Terry Fullerton there, employed somebody who had taken product to market before. And he was really good. He knew what to do, and I learned a huge amount from him. So he searched around and found somebody. He looked in Australia, looked in New Zealand, found that nothing was happening in New Zealand. Eventually found somebody in Canada who was interested in having a closer look at it. The Canadian entrepreneur, we'll call him Steve because that's his real name, he said, let me have a look, send one to me, and I'll try it out, see how we go. So he gave it, he had a look at it, he thought, this is terribly agricultural, you can't have galvanised steel around the edge, it's no. And he wasn't interested really. He showed it to his 11-year-old daughter who did gymnastic trampolining, and she got on it and she said, I think it's quite cool. He was really quite reluctant. He said, all right, well, we'll take it a bit further. So we sent him a bigger one, which he then took around to some of the stores. He tried to find his path to market, and he decided on a plan on what he was able to do, and he thought it was worth buying into. So a lot of communication went backwards and forwards, and he came out and visited. In 2003, he signed a royalty agreement with Enterprise, and one of the first things he said to me is, right, Keith, it's mine now. You might have to just face the fact that you'll never do anything with trampolines ever again. Okay? I was shocked. I was devastated. But I think he was protecting himself from the horrible inventor that just wants to have things his own way. He found that he could relate to me okay. He had some needs for technical advice. He wanted modifications to it, so I helped him out with the design. He wanted a round tube. He had to have green powder-coated frame. Made it a lot more expensive and much more difficult to make. He wanted a net on it because that's what they were doing in America at the time, a safety net. He wanted to break down into smaller parts, which made it hugely difficult because you put these smaller parts together and it all folded up, just like I'd imagined in the first place. We had to solve those problems. He had an aggressive patent program. He was horrified. I only had one patent in America. So if anyone in Australia could copy it. What about Europe? He did. So he went about an aggressive patent program, 14 patents in 7 different countries. He wanted samples for shows. So I helped the people at Levin make them, and here's one of the versions that they made. He also suggested some smaller ones. We've got an 8-foot one here and a rebounder version there. And here he is with his plan A, that I didn't know about at the time, just reading between the lines. Sell them to the big US manufacturers, get $10 million for it, and then on to the next project. That was his plan A. So he took them to the sports equipment shows, $60,000 a time to have a stand, and here it is at the show. Well, he took it to 2 shows, and while the big US trampoline manufacturers came and had a look, they didn't buy. He didn't know why, but the reason was they were both very close to going broke because they were both selling through Walmart. Walmart wanted their price down 10% each year. The price of steel went up the year after he bought into this, and they just both went broke. And there was no big US manufacturers in the US anymore. All went to China after that. So suddenly he found he had to go to plan B. So his plan B, because plan A didn't work, plan B was to start manufacturing in China because that's where it was going to be cheap enough. And so for my sabbatical in 2004, I spent most of my time doing drawings, going trips to the factory in China, 5 trips to China, went to the US and Canada to help with sourcing materials, develop users manuals, also engaged with the US standards. So there was a lot of work. Here's a drawing of a trampoline mat. I learnt how to draw for people who are going to do sewing. That was pretty interesting. Here's the people sewing in China. There's the trampoline mats down here. Here are the nets being made here. There's several rows of people doing this in China, in Xiamen on the east. Here's the user's manual, mostly done by me. I was really proud of that. The user's manual required by the standard is almost 200 pages, so people go, no, let's just make it. They don't look at the instructions. So this was to help people get to the instructions quickly. Here's the standards issue, the deal with the standards in the US is the standards in the US were based around spring-based trampolines that needed pads. So one of the things they said, when a trampoline is included for sale, it shall include this: a frame, a bed, that's the mat, a suspension system, frame padding. We didn't have any frame padding, we didn't need it. But if you go to the US and it's very litigious and they say, does it comply with the standard? And you have to go, well, not exactly, you've got a problem. So we decided what we'd have to do is to change the standard. So I got onto the standards committee in the US and we went about changing the standards, making the words a little bit more general throughout, and all the places that referred to pads, you say where appropriate or whatever. We came up with ways around it so that now our trampoline complied with the US standard. I'm still on the standards committee, and they pay, the company pays for me to go there each year, which is good because I can go and do other things and visit academics and go to universities. So that was in 2004. Now 2008, after 4 years of growth, they're still expanding sales, about 15% a year. SpringFree New Zealand was set up in 2008, and here's the Blenheim Road site, the old one. They've got a new one further down Blenheim Road now. They launched their own plant in China. So they were getting manufacturing done by somebody else who owned a factory in China, and that was a high-risk situation because when there was the big downturn, the factory stopped selling a lot to the US, started loading all his overheads onto the trampoline, and just kept putting his price up, and they said, we can't stand this. So they got out of that and made their own factory, which was a big risk. We used some of the engineering students from Canterbury to go there and be translators in their summer holidays, which is really valuable because not only did they translate, they could understand technical Chinese and technical English and technical drawings in Chinese. Very valuable. Other things that have happened with the company. We've got ongoing research on trampolines here. So here's a final year project, one of 5 final year projects in engineering since 1998 on trampolines. And here there's ongoing research, academic research. So there's got a paper in the medical journal looking at injuries on conventional trampolines, what causes them. And this other paper here where we've looked at the SpringFree trampoline and how effective it is and where it has limitations compared with conventional trampolines. So one of those papers is out, the other ones are in press. So the current state is 2012, 23 years. That's longer than 5 to 8, but from 23 years from the original idea. Mind you, I didn't do a lot for a lot of that time. 180,000 in the market total. Every 15 sold keeps a child out of hospital. When you compare it with conventional trampolines, that's, if you replace 15 conventional trampolines with these ones, that's about the figure. It's got a number of awards, as we've talked about. There's also 20 containers of New Zealand components shipped to China each year. So the pull-truded fiberglass rods, this is the part that's the spring that you're not allowed to talk about because it's a spring-free trampoline, but that's the fiberglass. This is the fishing rod, and these plastic components. This is made in Gisborne, these parts are made in Christchurch, and there's probably about 20 containers of product leaves New Zealand each year going to China to go into the trampolines. Also, they've employed over 12 University of Canterbury graduates, and they keep coming back because the graduates work there for a while and go and then take on somebody else. Okay, that's a trampoline story. So how do you tell what is a good idea? A good idea is not necessarily a good business opportunity. I think most of you know that. The inventor will think it is, but that's not necessarily the case. So here's a picture of me. I've got my walk-on-water shoes and I'm walking past the town hall. That is a product that is not going to make money. As an inventor, I was very proud of it and showed it around, but not going to make money. So what we want at the start is a good idea that is also a good business opportunity. So how do you know what is a good business opportunity? A reality check that I'm suggesting is to evaluate it as if you were an investor trying to make money out of it. Don't evaluate it as if you're an inventor who's invented it and you're going to therefore be rich and famous. There's a lot of information to help investors who want to make money out of it. And one way of looking at what investors will want to look at is to break it into these 4 areas again, and that's what you've got on your sheet. Now, I'm not going to go through all of these. I'll just pick out some of them to point out the way it works, because there's a lot of detail there. So the technology issues, well, the technology there, if it works reliably, it's attractive to an investor. If it's a fragile, tricky thing and you've got to keep adjusting it to get it right, it's not attractive to an investor. If the product life is long, and for the trampoline it is. The trampoline's going to keep going. They've got patents to cover them for 20 years. It's very attractive. If it's going to be soon superseded, in 6 months a better model of somebody else's is going to come out, it's not attractive. So there's a couple of things there. Market issues. The customer need, it's got to be clearly identified. With the trampoline, safety is the big thing. We can show you that this is safer. Can you get a patent, or has it got one? If you can't, it's not attractive. If there's no chance of getting a patent, other people are going to copy it. You know, an investor doesn't want to put $1 million in and have somebody else just copy it and take all the work that they've put in. The business and management team issues. Have you got a business team with a proven performance? In this case, the team that took it over had already taken stuff to market. And does the business team include the initiators, such as the inventor? Well, they have kept me involved because they find that they can work with me, which is, you know, a compliment to me, really. I'm pleased about that. The economics and finance. Well, have you got more than 12% profit after tax or less? There's got to be no doubts that it makes money, or the investor's not going to be interested. Break-even time, under 2 years is pretty good. I think for the trampoline, realistically, it was more like just over 3 years, and at that time they had paid off all their patents as well. All right, too much information, you think? There's a lot of information on that sheet, but and it is, but if the business fails, and I've had some little ventures that have failed, you'll point to at least one of the things on that sheet there, and you'll say, we didn't get that one right. So it captures most of the issues, that sheet there. It's from reference, it's from Timmins, as it says. Always keep your eye on the ball, says Bill Gates. All right, in summary, take care to start with the right idea that's got the features that fit in with those things on the back. There is a process, and you've got a map there. It's not accurate, but it gives you an idea. You can't do it on your own. You need to have a team of people with a range of skills, and you mightn't even understand theirs. It takes years, so be prepared to keep going. And you can get a good synergy between commercialisation and academic work if that's where you are, and that's where I happen to be. So you can get academics and commercialisation working together. All right, that's it. It was more than 3 minutes.